In this lesson, we'll talk a little bit about Java annotation. Annotation is a relatively new feature of Java, which was introduced in Java 1.5. Annotation contains information about code in a program, but it is not part of the code itself in the sense that with or without annotation, your program will compile and run in pretty much the same way. So you might be wondering, what's the use of annotation? It turns out that it is extremely useful, and these days is widely used by compilers, virtual machines, and many software tools for a variety of purposes. As we can see, annotation starts with @ followed by the name of the annotation. Here are some examples of annotations used for various purposes. The override annotation here is used by IDEs to detect problems when overriding a method. As we know, overriding is when a subclass has a method that has the same signature as a superclass method but different implementation. Overriding works with or without this annotation, so what's the point of having it here? The answer is that it is quite easy to make a mistake when overriding a method. For example, I may forget the response parameter here, like this, and think that this method overrides the doGet method in the superclass when it actually does not. By using the override annotation here, I basically tell the IDE that this method is supposed to override a superclass method, and the IDE can help me to check if it is indeed the case. If not, the IDE will give me an error message right away, so I don't have to wait until runtime to find out. In software development, discovering error early is always a good thing. In the second example, as the name suggests, the annotation will surprise some compiler warnings, and in this case, the unchecked warning that usually happens when mixing raw types with generic types. Most of you are probably quite familiar with this web servlet annotation, which is used by Java application servers to map requests to servlets. And in this example, annotations are used to help create web services, which we'll discuss in a separate lesson. Creating web services in Java used to be very tedious work that involved lots of code and configuration. But these days, with annotation and better tool support, it is much easier. Nowadays, to create a web service, you just need to implement them as regular Java classes and methods, and then simply annotate the functions as web service and web methods. Based on these annotations, software tools can automatically generate additional code and configuration and make it very easy to expose these functions as web services. The last example shows how a Java class is mapped to relational tables using annotations in the Hibernate framework. And we'll see more of this when we discuss Java Persistence API and the object relational mapping later. Overall, as we can see, annotations are widely used by IDEs, compilers, application servers, software tools, and libraries to make Java development a lot more efficient than before. This is particularly true for Java web development, where many frameworks and libraries make heavy use of annotation. In most cases, the annotations are already created by other developers, and all we need to know is how to use them. But I think it gives us better understanding of annotations if we also know how to create them. So let's see an example of doing that. First, I have a thought method here that tries to sort an integer array in ascending order. It's using the bubble sort algorithm, and the algorithm itself is not important here. All we need to know is that this method sorts an integer array and in ascending order. And to test if the sort method works correctly, I have created two test methods here, test1 and test2. In each method, I created an array, print out the array, call the sort method, print out the array again, and then check if the elements in the array are sorted in ascending order. In this case, for example, it starts as 4, 5, 1, and after being sorted, it should be 1, 4, 5. And similarly, in this method, it started as 1, 5, 1, 2, and after sorting, it should be 1, 1, 2, 5. And if the sort method works correctly, the test method should return true, otherwise it should return false. And in addition to these two test methods, I also have a helper method that prints out an integer array called print array. So to run the test methods, I also have a test runner class. And the easy way to run the test method is simply calling them inside the main method here. For example, I could do bubble sort test dot test1 and bubble sort test2, something like this. The problem with this approach is that when you change something in your test cases, you may have to change the test runner code as well. For example, if you want to add another test method, then you would have to change the code here and add a test3 here, save, recompile, and so on. And if you want to delete a test method, again, you have to change the code here, save, recompile, and if, for example, you simply want to skip a test and only run the other one, you have to comment one here and then save, recompile, and so on. So it's not the end of the world for a simple example like this, but for a complex project that involves many test cases, doing that is not very efficient or effective. A better approach would be creating a general purpose test runner that doesn't need to be changed as the test case is changing. So what we can do is we can utilize annotation, and the idea is to annotate the test methods with an annotation like this. And then in the test runner class, we can simply go through bubble sort test class and run all methods annotated by test. As you can see, this way, when we make changes to the test cases, we no longer need to change this test runner class. And this is, by the way, the idea behind test frameworks like JUnit and TestNG, if you know those frameworks. So how do we do this? Well, the first thing is, of course, creating a test annotation, which turns out to be pretty simple. This is how I can create the test annotation, and as we can see, it's very similar to a Java interface, except the additional @ here. And to create this annotation, we also need to use two other annotations, target and retention. Target, as we can see, specifies where the annotation can be used. Annotation can be used on constructors, fields, local variables, methods, package, parameters, and types like classes and interfaces. And on top of those, annotations can also be used on other annotations. In our case, we'll use the test annotation on methods like this. So our target would be method. Retention specifies how long the annotation is to be returned. It could be source, meaning that the annotation will only be returned in source code and it will be discarded by the compiler when the compiler compiles the source code. It can also be returned in the bytecode of class files, or it can be returned during runtime, which means the annotation will be stored in the class files and be available during runtime. In our case, we will need to access our annotation during runtime, so our retention is runtime. And this is the code for our annotation. Again, it's very similar to creating an interface with a couple of additional annotations, pretty simple. And once we have that, we can then use it to annotate our methods. And here I annotate the test1 method and then the test method, and that's it for this one. So now we have to run those test methods, and to access the annotation and run the test methods in the test runner class, we have to use some classes and methods in the Java Reflection API. You may or may not be familiar with Java Reflection, but in any case, it doesn't really matter here, as this example is about annotations, not Java Reflection. The code would look something like this. First, we load the bubble sort test class. This is a class that has a test and annotated test methods. And then for each method in the class, we try to retrieve the annotation. Notice that in this class, some methods have the annotation and some don't. For example, this helper method doesn't have the annotation. So in other words, this test annotation variable could be null. And if it is null, we know that method is not annotated and we skip that. But if it's not null, we try to invoke this method and store the return value in result. If we look at all the test methods, we can see that all of them return Boolean values. So we can cast the result into a Boolean and check if it's true or false. If it's true, we print out the method name and say passed. And if it's false, we print out the name and say it's failed. Again, if you are not familiar with these classes and methods in the Reflection API, don't worry about it. This example, again, is about annotations. So if we run this test runner code, and for some reason it's trying to build the CSNS2 project instead of just running this. Okay, now it runs. As we can see, the test runner class was successfully executed, and it ran both test1 and test2, and this printout are from the print array methods called inside test1 and test2. So everything looks pretty good. Okay? We have successfully added annotation, we retrieved the annotation, and we have invoked the method that are annotated, and the result shows that our sort method was actually implemented correctly, and that's great. Now the basic stuff works. Let's add a little bit more to it. So in testing, oftentimes we want to run a test case multiple times. For example, we may want to run test2 3 times instead of just 1. This is particularly necessary when the test input of a test case is randomly generated, in which case you would want to try multiple sets of randomly generated data as the input. So to do that, we may want to add an attribute to this annotation, something like this. And this would indicate that this test case should be run 3 times instead of 1. So how do we do that? Well, we can add something called element into our annotation. I usually call these things attributes, but the official name is element, and this is called element of the test annotation and the repeat element. To create an element is, as we can see, pretty simple. It's created as a very similar to a method declaration. So we simply create a method-like thing inside our annotation called repeat, and we can specify a default value. And so if a user doesn't specify it explicitly, by default it takes a value of 1. There are a few things I want to mention about annotation elements. As I mentioned, they are defined as methods. They can have default values. And also remember that the type of an element cannot be arbitrary Java types. They mostly have to be primitive types, like integer type or character type or a double type and so on. They could also be strings, class, enumerations, and other annotations, and array of these types. But these are pretty much all the types that they can be. They cannot in particular be user-defined class type or something like that. Once we have this repeat annotation, and we specify it here, and then we can change our test runner code to accommodate that. For example, here we only check whether a method is annotated or not, but in addition to that, we can also check whether the repeat element of that annotation is specified. So we can do something like this. If test annotation is not null, then we will run the test case multiple times. How many times? We'll run it from 0 to test annotation dot repeat ++i. So notice two things here. First, this is how we get the value of an annotation element, because an annotation element is defined as a method. We can simply call the method. And secondly, depending on the value of this repeat element, this part of the code will be executed either once, if repeat is 1, or n times, n being the value of repeat. So if we run this code again, we can see that now test 1 is run only once, and then test 2 was run 3 times because we have specified repeat being 3 for test number 2. Here are some examples of using elements. You can specify a value for the element. You can specify values for several elements, and the value of an element can be an array like this. There are also 2 common special cases you should remember. First, if an array like this has only one value, then the array braces can be omitted. In other words, this one is equivalent to this one because this array has only one value. The braces can be omitted. The second special case is that value is a special element, and you can omit the element name if it is the only element that needs to be specified. For example, again, this one is equivalent to this one because of the special element value, and the name of the element is omitted, and it's perfectly okay. So this is the end of this lesson. For more information, please check out the annotation documentation at this address. Thank you.